Thanks for coming, everyone. So me and Jeremy are going to talk for a few minutes just about nanotechnology in general, what it is, some applications of nanotechnology. I'm going to give you a specific example of research, as well as talk about our new club that we started and what our goals are going to be for the semesters.
Yep, and we're planning to bring nanotechnology to the forefront of the upfront. That's our written word.
So nanotechnology is a science that deals with molecules, systems, and technology at a nanometer scale. So just to give you an idea of what that is, bacteria and different cells are at the micron scale, so like 20 microns, 30 microns, which is 20,000 nanometers. These systems are at the 10 to 100 nanometer scales, so that's in virus range, antibody range. So you can imagine dealing with materials and molecules in the size of a virus. It can have some huge impacts for any different type of science, like medicine and electronics. So if there's one thing I want you guys to take away from this talk, it's how interdisciplinary nanomedicine is, or nanotechnology is. So you can tell that just by our majors. I'm chemical engineering, Jeremy's nursing. So pretty different, majors, but both bound by this science, nanotechnology. So here's some different applications of nanotechnology. First is nanomedicine, which me and Jeremy both work on in our last co-ops, and I'm still working on my co-op now. Nanomedicine involves different molecules, different treatments for disease, to develop safer and more effective treatments for different diseases such as cancer, which I'll show you an example of in a minute. There's also different applications for the electronics industry, such as semiconductors. Nano systems can use different nanomolecules to create better storage and better, more efficient electronic systems. And then lastly, the last example I have for you guys is nanomaterials, like the textile industry. A recent example was these things called nanogenes, which are stain-resistant, different stain-resistant genes. So if you spill something on yourself, it just slides right off instead of staining the genes themselves. So this is an example of nanomedicine research I worked on in my last co-op. So this is a nanoparticle up here. It's about 100 nanometers in diameter. Inside the red small dots there are a chemotherapeutic. As many of you guys might know, chemotherapy is pretty nasty and dangerous to healthy cells while they're being treated. So we're trying to, with this research, create a safer and more effective chemotherapy treatment. So we encapsulate the chemotherapies in this molecule here. It's a nanoparticle, and it's made of a polymer. And on the outside, the blue dots here are ligands, which can be recognized by different receptors, which are overexpressed in cancer cells and not overexpressed in healthy cells. So the cancer cell is more likely to take up the nanoparticle via endocytosis, and using a mechanism I'm not going to get into detail here, the nanoparticle breaks through the endosome, localizes at the mitochondria, and releases its drug directly to the mitochondria without harming any healthy cells, or little to few healthy cells. So these are some different images of nanomedicine that me and Jeremy worked on at the last co-op. In the center here is some nanoparticles in solution that we just made. In the bottom right are some transmission electron microscopy images of nanoparticles.
And then in the bottom center, there's a little neat picture of a vacuum-sealed rotating device that mixes the different components of nanoparticles to make these liposomes that form and carry the cancer-treating drugs. And then there's the finished product in the top right. And then over on the top right, we have a IC50, which helps find the specific dose of the olaparib, which is the drug that we use to treat ovarian cancer. So I wanted to talk about why we're doing this. So me and Jordan, we met in a fellowship together for our last co-op, which was all studying different types of cancers and how they can be treated using nanoscience. So we thought this was really cool, but there's got to be more to this nano industry and this nanoscience in general besides just medicine. So we want to make NU Nano. We're the nanoscience enthusiasts, and we strive to make this information available for anyone of any major at every educational level. So bring anyone, bring your brother, your sister, your mom, if they're a student, maybe bring them for a club. All right. So here's some stuff we want to do. We want to do seminars. We have speakers, different speakers from the labs around campus, as well as hopefully some different labs in Boston. We're going to have lab tours, and we want to just propagate this nanoscience news and information. We also hope with the different resources on campus to find opportunities for research, as we know undergrads have a lot of trouble finding research opportunities. And we want to do some journal critiquing and maybe some brainstorming of nano ideas. All right, so our first meeting will be on Wednesday, February 3rd at 6 p.m. in the YMCA room 106. Our meetings are going to be monthly on Wednesdays at 6 p.m. And our first meeting, we're going to have a great lecture by Dr. Thomas Webster, who is in the Chemical Engineering Department, and also a lecture by Latika Menon, who is in the Physics Department on nanoelectronics. You can reach us at our Gmail, Northeastern nano@gmail.com, and that's our e-board. We all have goggles. Yeah, and I guess I just want to leave with one more thing, saying that, so when I was first going to nanoscience and becoming interested in it, people are like, "You're a nurse. Why would you be interested in that? That's not what you do." But you can be whatever you want to be. If you're, you might be a chemical engineer, but if you're interested in baking, do that. Or if you're a baker and you want to be interested in MRIs, go do that. So, Jordan, anything else?
That's it.